Hello friends, today we solve problem on variable acceleration motion. So let's start. So here is a question. The acceleration of the particle is defined by the relation a is equal to 25 minus 3x square mm per second square. The particle start with no initial velocity at the position x is equal to 0. Determine the velocity when x is equal to 2 mm first. Second, the position when the velocity is again 0. Third, the position where the velocity is maximum and the corresponding maximum velocity. So here in this problem, the acceleration is a function of x, means it is a function of position. Okay, if the position of the particle changes, the acceleration of the particle keep on changing, means it is a variable acceleration motion. Okay, so here we have to calculate three unknowns. First, determine the velocity when x is equal to 2 mm. We have to first calculate what is the velocity when x is equal to 2 mm. Then we have to find the position when velocity 0. Okay, and third, the position where the velocity is maximum and the corresponding maximum velocity. So let's start the solution. Okay, so we know three equations here. First, v is equal to dx upon dt. Okay, this is our first equation. Our second equation, a is equal to dv upon dt. Okay, our third equation is a is equal to v dv by dx. Okay, here the acceleration is a function of x. Okay, not function of t. So we can use first two equations because here it is a differentiate with respect to t, and in question they give acceleration is a function of x. So we use third equation. Okay, we know, if we know acceleration, and we have to calculate velocity. From acceleration to velocity we simply integrate. Okay, if we know velocity and we have to calculate position, then we again integrate. Okay, so here we know the acceleration and we have to calculate velocity and the position, so we have to integrate twice. Okay, so let's start the problem. Given a is equal to 25 minus 3x square. Okay, and we have to determine the velocity. Okay, from acceleration to velocity, so we have to integrate. We have one formula, that is a is equal to v dv by dx. Okay, substitute a is equal to 25 minus 3x square. Okay, 25 minus 3x square. Here dx is in denominator, take on left hand side, which goes multiply. Okay, integrate on both sides. We have to calculate the velocity from acceleration, so we have to consider integrate. To integrate on both sides. Okay, so we get 25 minus 3x square dx is equal to integration v dv. Okay, so integrate first 20. Okay, so integrate 25x minus 3x cube by 3 plus c is equal to v square by 2. Okay, we get 25x minus x cube plus c or c1 is equal to v square by 2. So here c is a constant which is unknown. We have to find c1 first. So in question they mention particles start with initial velocity at the position x is equal to 0. This statement means x is equal to 0, v is equal to 0. This is our condition. At x is equal to 0, v is equal to 0. So simply substitute in above equation. So we get value of C1 is equal to 0. So we get the equation of velocity, that is v square is equal to 2 into 25x minus x cube. Okay, so v is equal to square root on both sides, we get plus or minus 2 into 25x minus x cube. Okay, so first they ask determine the velocity when x is equal to 2m. Okay, so simply substitute x is equal to 2 mm. Put x is equal to 2 mm. Okay, so we get answer v is equal to plus minus in root. Okay, if we solve this equation we get answer v is equal to plus minus 9.165 mm per second. Okay, this is our first unknown, velocity of particle when x is equal to 2 mm. Okay, second they ask the position when velocity is 0. They ask to find the position when velocity is 0. So we got the equation of velocity, that is v square is equal to 2 into 25x minus x cube. They ask what is the position of the particle when velocity is 0. Okay, so just substitute v is equal to 0. Okay, so v 0, 2 into 25x minus x cube. Okay, 2 on left hand side becomes 0, so equation becomes x cube is equal to 25x. Okay, x or x, yeah, remains x square is equal to 25 and x is equal to plus minus 5 mm. This is our second unknown. X is equal to plus and minus 5 mm when v is equal to 0 mm per second. Okay, our third unknown, they ask we have to find the position where velocity is maximum and the corresponding maximum velocity. Okay, so we in this question we use maximum function concept. The maximum function concept say if we differentiate the velocity we get the acceleration, and at the maximum value of v the acceleration is 0, means for v max, okay, acceleration is 0. So we have equation of acceleration, that is a is equal to 25 minus 3x square. Okay, so simply substitute, put a is equal to 0 mm per second square. So we get answer 0 is equal to 25 minus 3x square. Okay, so we get the value of x, it is plus minus. Okay, so here we have to find the maximum corresponding maximum velocity. So we just simply substitute in equation of velocity. The equation is v square is equal to 2 into 25x minus x cube. Okay, so we substitute x is equal to, if we substitute and solve this equation, we get value of velocity which is equal to 9.8 mm per second. This is our final answer. Thank you. If you like my video, please like, share and subscribe our channel. Thank you.